Three machines K, M, and P working simultaneously and independently at their respective constant rates can complete a certain task in 24 minutes. So whenever we have machines or people working simultaneously, what we can add are the rates. The sum of the individual rates equals the combined rate. And so if we add these individual rates, the rate of K, the rate of M, plus the rate of P, then we're going to have a combined rate of completing a task in 24 minutes, one task per 24 minutes. So that's the equation we get from the prompt. The question is, how long does it take machine K working alone at its constant rate to complete the task? So if we could figure out the rate of K, we'd be able to answer that question. So statement number 1 tells us that M and P working simultaneously and independently at their respective constant rates can complete the task in 36 minutes. So that means when we add the rate of M and the rate of P, we get a combined rate of one task in 36 minutes. Well, that's very interesting because if we combine it with the equation we got in the prompt, we can find the value of those terms. So we get that RK plus Rm plus Rp, which equals 1 over 36, equals 1 over 24. This allows us to solve for Rk. This allows us to answer the question. So statement number 1 is sufficient. Forgetting statement number 1, now we move on to statement number 2. Considering that alone, we're told that when K and P work together, the task is completed in 48 minutes. So adding the rate of K plus the rate of P, we get 1 over 48. Well, through a similar analysis, we'd be able to solve for the rate of M here, but we have no way to distinguish the rate of K from the rate of P. We know what they are when they're added together, but we have no way to determine what contribution K makes and what contribution P makes. And so this statement by itself is insufficient. So statement number 1 is sufficient, statement number 2 is insufficient, answer choice A.